Bright Duty. Every student matters.
Moving on to the next question. Why does color of copper sulfate solution change when iron nail is dipped in it? So we did this activity where we had a beaker and we had copper sulfate solution in it and we dipped an iron nail in it. We saw that the blue color of copper sulfate slowly fades away and there's a greenish, a light green color of iron sulfate. Why does this happen? This happens simply because copper is less reactive as compared to iron. So iron replaces copper from its compound, it kicks it out and takes its place in the salt. When it takes the place, the color of copper sulfate is lost because copper sulfate no longer exists. And copper is kicked out, which gets deposited on the nail. So basically the color is lost because a more reactive metal, which is iron, replaces a lesser reactive metal, which is copper, from its solution. Another question is, give an example which is not the one that we did in the activity before. So here we have an example. This is potassium iodide. When it reacts with lead nitrate, it gives rise to, so this is what happens in a double displacement reaction is that there is an exchange of ion. So the metals exchange their ion. So lead takes the iodide ion and it becomes lead iodide, and potassium becomes nitrate. Right, and this has occurred. So we have our double displacement reaction where there is an exchange of ions. Let's move on to the next question, which says identify the substance that has been oxidized and the substance that is being reduced in the following reaction. So the reaction here is 4Na plus O2 forms Na2O. Now you know that for reduction and for oxidation we have a very simple rule. Any substance which gains oxygen or loses hydrogen is getting oxidized. Any substance which loses oxygen or gains hydrogen is getting reduced. Right? So with that in mind, let's address this question. So we know that Na initially did not have an oxygen atom with this and now it does. So this process is of oxidation. So the substance being oxidized is sodium. But since oxygen is getting a metal attached to it, that is why it is getting reduced. So this process is of reduction. Right? So when you are answering a question like this, it is always better that you draw these lines and you mention on them that this is oxidation happening and this is reduction happening, and then you write the substance like sodium and oxygen like I've mentioned here. Okay, let's do another example of the same kind. So here we have copper oxide with hydrogen. It reacts to form copper and water. So you see that here it had an oxygen and now it does not. So this is a process of reduction. Here it did not have an oxygen and now it does. So hydrogen is getting oxidized. So the substance being oxidized is hydrogen and the substance being reduced is copper oxide. So it's a very simple deal. You remember two things, that for oxidation either you have to gain oxygen or you have to lose hydrogen, whereas for reduction it's the exact opposite, either lose oxygen or gain hydrogen. Once you know that, these questions will be simple, but I do suggest that you draw and demarcate the substance being reduced or oxidized. Now identify the oxidizing agent. What is the oxidizing agent? Very simple. Oxidizing agent is the substance which gets reduced. So any substance which gets reduced is helping the other substance get oxidized, and that is why it is called as oxidizing agent. So we have to identify here which of the following is oxidizing agent. So here you can see that lead Pb3O4 initially had oxygen but now it does not. So this has gone through a process of reduction, and this has gone through a process of oxidation because it has lost hydrogen. So whichever substance, I told you this before, oxidizing agent is the substance which gets reduced. So your answer here is Pb3O4, which is lead oxide, right? Simple deal, but don't get confused between the substance which gets oxidized and the oxidizing agent. Now here we do the simple thing again. We see magnesium had no oxygen, but now it does. High water had oxygen before and now it does not. So this is getting reduced. And magnesium didn't have oxygen, but now it does, so it's getting oxidized. So the substance which gets reduced is water, and that is our oxidizing agent. Now here we have copper sulfate and zinc. You see it had oxygen, but now it does not. So this process is of reduction. It didn't have oxygen and now it does. So this is of oxidation. Substance which gets reduced is our oxidizing agent. So answer is USO4. Now this is valium. You've not seen this metal in your common day-to-day equations, but that's alright. You don't need to go to the depth of the compound. So you see here that it has oxygen and now it does not. Simple as that, and this is enough to know that this is reduction. This is oxidation because oxygen is added. So the substance which gets reduced, that is V2O5, is our oxidizing agent. So we have our answers as lead oxide, water, CuSO4 and V2O5. This suggests that a substance which is getting reduced will be the oxidizing agent. To get reduced, an element has to either lose oxygen or gain hydrogen. The next question says that during electrolysis, a few drops of H2SO4 is added to water. Why? So when we are electrolyzing water, we add a little bit of acid to it. Why is that? This happens because pure water is actually not a conductor of electricity. Water conducts electricity by the virtue of ions present in the water. So we add a little bit of HCl, H2SO4, so that it can start conducting electricity. Very simple reason, it doesn't participate in the reaction, it just makes it a conductor for the electricity. The next question is identify the substance being oxidized, the substance being reduced, the oxidizing agent and the reducing agent in this equation. So let's see here. First let's start with our simple making lines to see which substance is getting reduced and oxidized. This has oxygen, now it does not. This is reduction. This had hydrogen. So this hydrogen did not have an oxygen, but now it does. So this is oxidation. Now substance which gets oxidized here is HCl. Substance which is getting reduced is MnO2. The oxidizing agent is the same substance which is getting reduced. So it will also be MnO2. The same substance which gets oxidized is also the reducing agent, so HCl, right? And so this way we have done this equation. The questions might seem tricky at first, but they really need your concentration. You just have to keep the clarity of what is being oxidation and what is reduction, what is an oxidizing agent and what is a reducing agent. So now we will be discussing the back exercise of our books. We'll be talking about all the questions and understanding how to approach them in examination. So let's begin with the first question. It says, which of the statements about the following reaction are incorrect? Keep in mind it's incorrect. So PbOC forms 2Pb and CO2. Lead is getting reduced. So let's first do it for our own selves. What is the reduction and oxidation happening here? We know that this is a reduction. And we know this is an oxidation process happening, right? So is lead getting reduced? Yes, lead is getting reduced. Carbon dioxide is getting oxidized. Carbon dioxide is not getting oxidized, carbon is getting oxidized. Carbon is getting oxidized, true. Lead oxide is getting reduced. So if you see here that lead oxidized is actually in fact getting reduced. So this is also correct answer. This would be incorrect because lead is not getting reduced, lead oxide was getting reduced. So we have the two incorrect options are A and B. So this is our answer, that lead is getting reduced is wrong and carbon dioxide getting oxidized is wrong, because these are the products. Products are not getting reduced or oxide, they are the products of the equation. In fact, lead oxide and carbon were going through the reaction. The next question says Fe2O3 plus Al forms Al2O3 plus Fe. What kind of reaction is this? For a reaction to be combination, two substances have to combine to form one, which is not happening here. For a double displacement reaction, there has to be an exchange of ions, which is not happening here. For a decomposition reaction, one substance has to break into two or more substances, again not happening here. For a displacement reaction, a more reactive metal displaces a lesser reactive metal from its compound. This is exactly what is happening here, because aluminium is more reactive, it is displacing the iron from its oxide. So this is a displacement reaction. What happens when dilute hydrochloric acid is added to iron filings? Simply to address this question, let's try and form an equation. So we have iron filings and we have HCl. What happens when we mix metal with HCl? You will have also, we will also study the same reaction in the chapters metals and non-metals. But for now, it's very simple to see that hydrogen will get displaced because of this position in the reactivity series. So this is about, this is a question of displacement reaction, that hydrogen will get displaced because iron is more reactive. It will form FeCl2 plus H2. As you can see here, the equation is given, and so the question was what will happen. So hydrogen gas will be released, as you can see here, and iron chloride would be formed. So the answer is part A, hydrogen gas will be produced and iron chloride will be formed. Why is this? Why not other options? Chlorine gas and iron chloride. So this will not happen because iron hydroxide will not be formed by this equation by reacting with acid. Reaction will take place because there is a more reactive metal present with a solution of a less reactive metal, and again this will also not happen. So that is why this is a question based simply on the concept of displacement reaction. The next question is, what is a balanced equation and why do we need to balance the equations? This is a very important question, and it's a very fundamental cause that you need to understand. It's very simple. So chemical equation in which number of atoms on different elements on both sides is equal is called as chemical equation. Is called as a balanced chemical equation. So when the number of atoms on different sides of different elements on both sides of the chemical equations are equal, then this is called as a balanced chemical equation. Why do we need to balance a chemical equation? We need to balance a chemical equation because of law of conservation of mass. The law of conservation of mass states that matter cannot be created or not be destroyed. So if matter cannot be created nor be destroyed, it means new molecules or new atoms, elements cannot be formed. And for the same reason, we need to keep the number of elements on either side same. So for the mass of both sides to be same, there has to be the total number of atoms of each element should be equal on both sides. Right? So it's a simple question, but it is commonly asked in examination, so you can try to memorize it. Translate the following statements into chemical equations and then balance them. Hydrogen gas combines with nitrogen to form ammonia. So hydrogen is H2, nitrogen is N2, combines to form ammonia, which is NH3. We have converted the equation, now we need to balance it. We only have two elements, it's a simple question. So you see there's one nitrogen and three hydrogen here, that's why I've written it like this. Now we will start by balancing hydrogen because it's more in number. So to balance out 2 and 3, we realize that the common ground has to be 6. cannot make it 4. So to make it 6 on both sides, we add 3 here and we add 2 here. Because if it were one element, then we could have made it 4, but it's multiples of 3's and 2's, and that is why the minimum number we'll achieve will be 6. So if we multiply it by 3 and we multiply this by 2, we'll get 6 on each side. But in this process, the nitrogen will again change its number. So you see that nitrogen now is 2, and here it was already 2. So when we multiply this by 2, we again get 2 here, and so our equation is balanced. So final equation is 3H2 plus N2 forms 2NH3. Understood? Now let's move on to the second part of this question. Hydrogen sulfide gas, which is H2S, burns in the air. So by air, it always means oxygen. You have to keep this in mind. Although air has different components, but when we are talking about burning in the presence of air, we mean oxygen. To give water and sulfur dioxide, so forms H2O plus SO2. Now let's start. So we have already formed the equation. Now let's try to balance it. We have hydrogen, we have oxygen, and we have sulfur. We have 2 hydrogen here and 2 here. We have 1 sulfur here and 1 sulfur here. We have 2 oxygen here and 3 here. Now you again, like I explained in the previous part, to achieve a middle ground, we'll have to come up with 6 oxygen on each side. So we multiply this by 3. We get 6 here. Now here, if I multiply this by 2 and also this by 2, I will get 4 and 2, 6. On doing this, I'm balancing out, I'm making this into 6. But I have to check for hydrogen and sulfur also. So we see now hydrogen was 2 and now it's 4 here. So we need to change this here, we need to add a 2. When I add a 2 here, sulfur becomes 2, sulfur is already 2 here. So that is also sorted. So we have now equal number of hydrogen, sulfur and oxygen atoms. I started with oxygen because it had the highest disparity. On shifting the numbers for oxygen, I realized that hydrogen also needs to be changed now. And then while fixing it for hydrogen, I realized that sulfur was balanced on the way, right? And this is for our final equation, 2H2 plus 3H2O forms 2H2O plus 2SO2. Part 3 talks about barium chloride. So we know barium is Ba and chloride is Cl, so BaCl2. Reacts with aluminium sulfate, Al2SO4 whole thrice, to give aluminium chloride, AlCl whole thrice, and barium sulfate. So this is the equation. The word equation is converted into this symbolic representation. Now let's try to balance it. We have barium, we have aluminium, we have chlorine, sulfur, oxygen. Barium is 1 here, 1 here. Aluminium is 2 here, but 1 here. Chlorine is 2 here, 3 here. Sulfur 3 and 1. Oxygen 12 and 4. Now there are a lot of elements here, and like I've told you before, we are going to start balancing with metals first. So we start with aluminium because barium is already balanced for now. Now aluminium needs to be doubled on this side. On making aluminium double, this will become 2, but this will become 6. So to make this balance out this 6, we need to put a 3 here. Now barium also becomes, barium becomes 3. So to make balance it out, we add a 3 here, and now barium is also 3 on both sides. So barium is balanced, aluminium is balanced, chlorine is balanced. We need to check for sulfur and oxygen. Barium 3 here, 3 here, chlorine 6 and 6, aluminium 2 and 2, sulfur here we have 3, and again here we have 3. So it happened on its own. Oxygen we have 4 3s are 12, and here again we have 4 3s are 12. So our equation is balanced, and this gives us our final equation, 3 BaCl2 plus Al2SO4 3 forms 2ACl3, and 3 BaSO4. Start with metals, go on developing changes in other elements which are changing. Like when I changed for aluminium, chlorine changed, then I tried to balance chlorine. When I tried to balance chlorine, barium changed, so I tried to balance barium. And by that, I was done with all the balancing. So this is how you go about balancing an equation. Now we have potassium metal, which is K, reacts with water, H2O, potassium hydroxide, KOH, and hydrogen gas, H2. So now that we have converted it into a symbolic representation, now let's try to balance. We have 1 here, H2 here, 2 here, oxygen, H is 3 here, right, because we have 1 here and 2 here, so we have 3, and oxygen is 1 and 1. So since hydrogen is the only one out of balance right now, we'll start with that. So for balancing out hydrogen, what we can do is, if I put a 2 here and if I put a 2 here, I will have 4 here and I will have 4 here. So my hydrogen gets balanced like this. But the problem is I've imbalanced potassium, so I have to put a 2 here to make potassium also 2 on both sides. So you see what I'm doing here? I start with hydrogen. I know that here, although it's 2 and 3, it can be taken to 4 because it's in separate compounds. I put a 2 here and I put a 2 here, it becomes 4 on both sides. By putting a 2 here, the number of potassium was increasing, so I put a 2 here to balance it out. 2K plus 2H2O forms 2KOH plus H2. This is again, our equation is balanced now. Let's move on to the next question, which is again a balancing question, but here we don't have to convert it from word form to symbolic form. So simply let's get to the elements. We have hydrogen, we have nitrogen, we have oxygen, we have calcium, and that's it. We have 1 hydrogen here and 2 here, so we have total 3. Here we have only 2. For nitrogen we have 1 here and 2 here. For oxygen we have 3 plus 2, 4. So we have 4 here, and here we have 3 2s are 6 plus 1, 7. For calcium we have 1 here and 1 here. So calcium, as you can see, is already balanced out, so I'm not starting with the metals now. So I will try and start with nitrogen. If I try to balance, we can start with nitrogen or hydrogen or oxygen, whichever you want to start with first. In this situation, all will lead to the answer. So what we can do here is, let's start with hydrogen. If we start with hydrogen, we will see that here there are 3 and here there are 2. So if I put a 2 here, it will become 6, and if I put a 2 here, it will become 6. It will become 4, and we have 2 hydrogen here and we have 2 here, so it becomes 4. And if we have 2 and 2 here also becomes 4, right? So now that we have tried to balance hydrogen, let's see what it has done to N. So now we have 2 nitrogen atoms. So nitrogen also got balanced. Let's talk about other elements like oxygen. So oxygen here became 6 plus 7, 8, and here it also became 2 plus 6, 8. So again, oxygen also got balanced. The whole equation got balanced just by trying to balance out hydrogen. Because when I changed it for hydrogen here and there, it automatically shifted the numbers for nitrogen and oxygen. Now we have NaOH plus H2SO4 forms NH2SO4 plus H2. So let's start. We have Na, we have O, we have H, and we have S. We have 1 here, 2 here, we have 1 and 4, 5, we have 4 and 1, 5, hydrogen we have 1 and 2, 3, hydrogen we only have 2, sulfur we have 1 and 1. So you realize that hydrogen is the only thing that is out of balance right now. Hydrogen and oxygen are the only things. Sorry. For this question, we will start with metals because the metal sodium is out of balance. To balance out sodium, we will put a 2 here. Because we wanted it to be 2 on both sides, we put a 2 here. Now that sodium is balanced out, we will see what effect it has on O and H. So on putting a 2 here, O becomes 2 plus 4, 6. And here it was 5, so it's still imbalanced. We'll have to look into that. And hydrogen becomes 2 and 2, 4. Now we know that there is an extra proportion of O and H here as compared to this. So if I put a 2 here, this will make it, this will balance everything out. Hydrogen becomes 4 here and oxygen becomes 6. This sorts our problem, and now we have 2 NaOH, H2SO4, Na2SO4 plus 2 H2O. So you only had to make these 2 additions. Always start with metal if the metal is imbalanced. So here it was 1 and 2, and that is why I started with metal and then go on following the other elements. We have 1 sodium here, 1 here. Chlorine we have 1 here, 1 here. Silver we have 1, 1. Nitrogen we have 1, 1. Oxygen we have 3, 3. So this equation is already balanced. We don't need to do anything to change anything, and that is why we can just, the balance equation is just this original form. Now we have barium, we have chlorine, we have hydrogen, we have sulfur, we have oxygen. Barium is 1, 1. Chlorine is 2, 1. Hydrogen is 2, 1. Sulfur is 1, 1. Oxygen is 4, 4. So this is very simple. You can see it from here that H and Cl need to be doubled in the product. So we put a 2 here, the whole equation gets balanced. It's a fairly simple question. You can see it directly when you try to make this LHS RHS that this equation will be sorted if we multiply this by 2. Now let's do some more balancing questions. So this part expects you to write a balanced equation for the reaction. So we have calcium hydroxide plus carbon dioxide forms calcium carbonate plus water. So we have Ca, OH whole twice plus carbon dioxide CO2, CaCO3 and H2. As you will count, the number of atoms are already balanced here, and that is why we don't need to balance it. For the case of zinc, silver and reacting with silver nitrate and forming zinc nitrate and silver, the reaction showed that although zinc and silver were balanced, NO3 was not balanced because it was getting multiplied by 2 here. So we put a 2 here, and because silver also gets double, we put a 2 here and the equation gets balanced. So initially N and O were one 1, Ag was 1, 1, N was 1, 2, it was 3, 6. So we knew that we needed to multiply this by 2, so we put a 2 here, and to balance out, when we put a 2 here, this also becomes 2, and so we have to multiply and add a 2 here to balance out the equation. Aluminium and copper chloride form aluminium chloride and copper. So we take 2Al. So in this equation we take aluminium, copper chloride, AlCl3 and Cu. Now to balance this equation, again we follow the same procedure. As you can see in the initial equation, the number of chlorine was imbalanced and the metals were balanced. So we multiply 3 by 2 and 2 by 3 to get the balanced form of equation. It's a fairly simple question. This part of questions is relatively easy because only one or two element maximum need changing. Barium chloride and potassium sulfate form barium sulfate and potassium chloride. So again, barium chloride is BaCl2. This is K2SO4, BaSO4 plus 2KCl. So this equation was balanced, only that only the problem was that Cl needed to be doubled, and so was potassium. So we put 1, 2 here and the equation got balanced. Like I told you, this part is fairly simple, only one or two elements need changing. So we could see that K was 2 here and so was Cl, and here if we put this 2, the whole equation gets balanced. This next question expects the balanced equation along with the type of reaction. So it says potassium bromide with barium iodide forms potassium iodide and barium bromide. KBr plus BaI2 forms Ki plus Br2. K Br BaI. This is 1, this is 1. Br is 1 here, but it's 2 here. Barium is 1 here, 1 here. I is 2 here and 1 here. So you see that it is actually quite simple. You see that if we added 2 here, then K and I would get balanced out, and that is all you need to do, because but when you do that, when you put a 2 here, K will also need changing, and you put a 2 here, and that will completely fix your equation. So when we put a 2 here, what happens is this becomes 2, and this also this becomes 2, and this becomes 2. So this to balance it out, we also put a 2 here, and with that this also happened. So we have 2, 2, 2, 2, 1, 1 and 2. So it's again balanced. This type of reaction is a double displacement reaction because ions are being exchanged, right? So it's a double displacement reaction. The next reaction is of zinc carbonate and zinc oxide. Zinc carbonate breaking up to give zinc oxide and carbon dioxide. Zinc carbonate breaks to give ZNO plus CO2. This equation is balanced on its own, so we don't need to make any changes, and the reaction is a decomposition reaction because one element is breaking down to give 2 or more substances. The next is hydrogen and chlorine. So H2 plus Cl2 forms HCl. Now in this equation, what happens is that we'll again have to balance it. Very simple, you have already done this before. Put a 2 here and the equation gets balanced. This is a combination reaction because two things are combining to form one compound. Magnesium plus HCl forms MgCl plus H2. So in this equation, what's happening is that Mg reacts with HCl to form MgCl2 plus H2. Again, this equation is already not already balanced. So for this, we need to add 1, 2 here, which will balance out this Cl, and by that all the equation get balanced. And this reaction is a displacement reaction because a more reactive metal, which is magnesium, is replacing hydrogen, a lesser reactive element. Now let's move on to the next question, which talks about exothermic and endothermic reactions. So exothermic reaction is a reaction in which heat is released. It is denoted by adding plus heat sign at the end of the equation on the right side. An endothermic reaction is the opposite. It's a reaction where heat is absorbed, and it is denoted by writing plus heat in the reactant side of the equation. The examples of exothermic reaction can be burning of fuel. Any kind of burning actually releases heat, and that is why it is an exothermic reaction. Whereas decomposition of substances absorbs heat, and that is why it is a endothermic reaction. So that is about these two types of reaction and their examples. If you want, you can give equations. or otherwise you can just write it in forms of burning of material like I've written here, combustion reactions and thermal decomposition reactions, right? The next question is, why is respiration considered an exothermic process? So in the process of respiration, what happens is that we take in oxygen from the air that we breathe and we take glucose from the food that we eat. Our body combines these two things to release a lot of energy, which is the energy that we are using to for all our bodily metabolic processes. Even for the movements of hands, for thinking, all the processes are carried out by that energy. So this process releases energy. That is why the process of respiration releases energy. That is why we can survive as organisms. And the equation goes like glucose plus oxygen in the presence of water forms CO2 plus water and releases a lot of energy. That is why respiration is considered an exothermic process. Why are decomposition reaction called the opposite of combination reaction? Explain with examples. So decomposition and combination are opposites because in a decomposition reaction, one substance breaks to form two or more substances. Whereas in combination reaction, two or more substances combine to form one substance. So that is how they are opposite. The reactant and product side look the exact opposite. And in decomposition, a single compound breaks to two or more substances, whereas in combination, two or more substances combine to form a single compound. The reaction of decomposition can be electrolysis of water, of combination can be burning of carbon in presence of oxygen. Write one equation each for decomposition reaction where energy is supplied in form of heat, light and electricity. We already covered this in the chapter, but let's just review it. So one process of heating can be heating of iron sulfate to release iron oxide, SO2 and SO3. It is a thermal decomposition. A decomposition in the presence of light, which is photolytic decomposition, happens with silver chloride and silver bromide, which is also a silver chloride and bromide are compounds used for photography. And electrolytic decomposition happens when we are doing electrolysis of water, which we did as an activity during the chapter as well. What is the difference between displacement and double displacement reaction? Write equations for both. So displacement reaction is when a more reactive metal displaces a lesser reactive metal from its solution, whereas double displacement is simply an exchange of ions between two solutions. So they do sound similar, but they in fact work on different principles. An example of displacement is Fe, iron replacing copper from its own sulfate solution. Whereas an example of double displacement reaction is sodium sulfate and barium chloride exchanging their ions of sulfate and chloride. In refining of silver, the recovery of silver from silver nitrate solution often involves displacement by copper metal. Write down the reaction. So it's very simple, you know that a silver nitrate has to go through a displacement with copper. Copper is more reactive, so it will displace silver. And copper nitrate will be formed along with silver. Silver will be removed and then it is pure silver is obtained in this form, which can be used for producing jewelry or whatever further purposes. What do you mean by precipitation reaction? Give example. So whenever a substance is formed which is insoluble in the solution and settles at the bottom, then it is called as a precipitation reaction. Explain by giving examples. So we have sodium sulfate and BaCl2, both were aqueous dissolved in water, but when we reacted them, BaSO4, a white precipitate was formed which did not in fact dissolve in water and settles at the bottom, and NaCl dissolved in water. This is an example of precipitation when an insoluble solid called precipitate separates from the solution. Explain the following in terms of gains and losses of oxygen with two examples each. So first is oxidation. We have already discussed this previously. Oxidation means you either gain oxygen or you lose hydrogen. So example of gaining oxygen would be Cu gains oxygen to form CuO. An example of losing oxygen, losing hydrogen would be H2S loses H2 and it gets oxidized. So sulfur here loses H2 and gets oxidized. This is also another form of oxidation. Reduction is the process of gaining hydrogen or losing oxygen. So here it can go like copper oxide loses oxygen and hence it gets reduced, or it can be H2S which H2S where sulfur loses hydrogen and forms sulfur metal and again gets reduced in the process. So for reduction it can be gaining of hydrogen or losing of oxygen, and the opposite stands true for oxidation. A shiny brown color element X on heating in air becomes black in color. So what is the shiny brown color element? The answer is copper. Name the element X and the black colored compound. When copper corrodes in air, it forms a blackish layer of oxide on it. So the layer formed would be CuO and the metal would be copper. Based on the color you can tell what is this compound we are talking about. If it was a reddish brown substance and a silver metal, then it would have been iron forming rust on corrosion. Why do we apply paint on iron articles? We apply paint on iron articles to cut its contact with air and water so that it does not go through the process of rusting, which makes the metal weaker and it loses its strength. Oil and fat containing food items are flushed with nitrogen. Why? Oil and fat containing items are flushed with nitrogen because nitrogen is an inert gas, and that is why it can prevent the oxidation of oil and fats to become rancid. So if you did not insert nitrogen in these packets, then what would happen was that they would get oxidized and rancid, which will give a very bad taste and smell. So to prevent rancidity, we flush these packings with nitrogen gas. The last question is explain the following terms with one example. So one is corrosion. So corrosion is the process where a metal deteriorates as a result of chemical reaction with air, water and chemicals. So anything that when added to the metal by natural contact deteriorates its quality is called as corrosion. Example can be rusting of iron, converting of copper into copper oxide. There also corrosion happens in silver. As you see, they get tarnished, and sometimes copper also gets a green layer of copper carbonate. So there are many metals which get tarnished with time, and one example given here is of iron converting into rust. The second was rancidity. So the reaction of oxidation of fat and oils that can be easily noticed by a change in taste and smell is called as rancidity. For example, butter becomes sour in taste and gives a foul smell when kept at the room temperature for a long time. That is why we cannot keep butter outside. It becomes really bad in taste. You can easily detect that it has become rancid. It can be prevented by flushing nitrogen, adding antioxidants and keeping the material in airtight containers. So that is all for the exercise of this chapter. And we have discussed all sorts of questions ranging from balancing equation, from types of equations, and from the two concepts of rancidity and corrosion. Thank you.